Hi, my name is Stephanie, and I am an experienced American tutor. I will be helping you get through the mathematics past questions of the joint admission and matriculation board examination. I hope you enjoy my tutoring. Thank you.
And this type that we're going to be going over is type D. Question 2 wants us to convert 27 base 10 to another number in base 3. So in order to do this, we have to take 27 and divide it by 3 to get an answer. Take that answer and divide it by 3, get an answer, and do it over and over again. We're going to be paying attention to the remainders and using that to get our new number. So starting off, we take 27 divided by 3, which is 9, so we get a remainder of 0, and we write down 0 over here. Then we take that answer that we got, which is 9, and divide it by 3, which is 3. We have a remainder of 0, and we write that over here. 3 divided by 3 is 1 with a remainder of 0. I got this 3 from up here. It was the answer from our previous division problem. Again, we have a remainder of 0. So this time, we're taking 1 because that's the answer that we got. 3 into 1 does not happen. So it would be 0, and you'd be left with a remainder of 1. So you put down that 1. To get your final answer, you would simply look up, go up the column that you just wrote. So it's going to be 1, 0, 0, 0, base 3. And that's your answer. Question 4 wants us to evaluate 1.25 times 0.025 over 0.05 correct to 1 decimal place. So the first thing that you need to do is simplify what all of these decimals mean. You could go and do the math with the decimals, but there's an easier way to do it. 1.25 is the same as saying 125 out of 100. And 0.025 is the same as saying 25 out of 1,000. Literally, this is read as 25 thousandths. And over here, this would be 5 out of 100 because it goes tenths, hundredths, 500ths. So now that you have that, you can set up the problem to use the same numbers as before, but this time in the new ways that you've written them with the fractions. So we have this form, and then to simplify further, we can work with this section right here. Remember that when you divide a fraction, you can multiply by its reciprocal. So here we have multiplication, and we're multiplying by the reciprocal, which means I flipped this. Instead of 5 over 100, it's now 100 over 5. Once you have this set up, you can just start simplifying. So this 100 will cancel with this 100 up here. Each of them cancel to 1. This 5 can go into this 25. So the 5 cancels to 1 and the 25 cancels to 5. Now you're left with 125 times 5 over 1,000. So that came from this, this, and this. Everything else had canceled to 1. All you're left to do is some simple math of 125 times 5, which is 625, over 1,000, which is just 625 thousandths. So you can put in your decimal, and it's 0.625. But remember, they ask for 1 decimal place. So you simplify it down to just 0.6. Question 5 asks us to calculate the time taken for 3,000 naira to earn 600 naira if invested at 8% simple interest. So the way that I've solved this is I've said to first take the equation for simple interest. So you have here your principal, your rate, time divided by 100, and that will give you your interest. And so let's keep in mind what they're asking here. They said calculate the time taken. And so what you would want to do is you would want to solve for time. So that's what I've done in steps 2 and 3 here. I've simply isolated this part. So first I took and multiplied by the denominator on both sides, so that I had 100 times the interest gives me the principal times the rate times time. And then I divided by principal and rate to get time on one side. I had time is equal to 100 times the interest divided by principal times rate. So your next step would be to plug in the numbers that they already gave you. So you have 100 as a stand-in from here, 600. You are earning the 600 as your interest. That is your interest. And then At the bottom is the rate. This is 8% is the rate, and the 3,000 is the principal. So you're putting in 3,000 at a rate of 8%, and you want to make an interest of 600. The time taken will be what you get when you work all of this out. So all you have to do is cancel these zeros so that you're left with 100 times 6 over 30 times 8. And you can simplify the 30 and the 6. So the 6 reduces to 1 and 30 to 5. So now you just have 100 over 5 times 8, which is 100 over 40. Again, you cancel zeros, and you're left with 10 over 4, which is the same as 5 halves, which is the same as saying 2.5 years, which is your option C. Question 6 wants us to simplify, and I've rewritten what they had here so it's a little clearer to see. So it's 3 to the negative 5n over 9 to the 1 minus n multiplied by 27 to the n plus 1. So what you're going to do is you're first going to take this base number and this base number and convert it into one where it's base 3. So 9 is the same as saying 3 squared. So now you have 3 squared to the 1 minus n. So nothing has changed from here to here except the notation. I just changed 9 to 3 squared. I do the same thing with the 27. 27 is equal to 3 cubed. So you're going to take 3 cubed to the n plus 1. But since these are exponents, it's squared times 1 minus n. So the previous exponent that was already there, this 1 minus n, is now being multiplied by the 2. And this n plus 1 is being multiplied by 3. So, as you can see here, I expanded the 3, so I said 3 times n and 3 times 1. So now this is 3 to the 3n plus 3. Over here, I've also done the same thing with this part. I said 3 to the 2 minus 2n. So why is this on the bottom now? This negative over here on the negative 5n means that it's just on the bottom. So now I have 3 to the 5n times 3 to the 2 minus 2n, and that's in a fraction underneath 1. So 1 over this quantity times 3 to the n plus 3. Okay, I promise things will start to get a little clearer now. So that means that I can just take this top part and plop it right over this, because 1 times this whole number over here will just be this number. So now I have this 3 to the 3n plus 3 over 3 to the 5n times 3 to the 2 minus 2n. So now what I can do is say these all are a base of 3. So that means I can combine all of these exponents in a way. So now I have this top part, 3 minus 3n plus 3, and I left it as it was. And then I said subtract from that, you're subtracting this quantity. So you can add these two because they are right next to each other. This is being multiplied by this, and when that happens you can add the exponents. So I've added them, but since they're on the bottom half of the fraction, I have to subtract them from the top half of the fraction. So simplifying even further, I find I have a 3n minus 5n and then plus 2n. That gives me 0. And 3 minus 2 is 1. So I have 3 to the 1 power, which means that my answer is just 3, which is your option over here for B. Question 7 tells us if log base 10 of 4 is equal to 0.6021, evaluate log base 10 of 4 to the 1/3 power. So all you have to do is recognize this form. And you also have to know what to do with this exponent. So essentially, just remember that log base 10 of 4 is equal to this set of decimals. So over here, we have 1/3 times log base 10 of 4. How did I get there? I took this exponent and I put it over here, because by the rules of exponents, you can do that with logs. So now I have 1/3 times the log base 10 of 4. So the next step would be to recognize this part as this. That means I can replace it with this. So that's what I did. Now I said 1/3 times 0.6021. So then what I did from there was I said that multiplying by this fraction is the same as dividing by 3. So I did some long division, and I found that 0.6021 divided by 3 is 0.2007, which matches your option for answer B. Question 8 wants us to simplify, and it has the square root of 5 multiplied by the square root of 147 minus the square root of 12 over the square root of 15. So the way that we want to work this out is we want to start breaking things up. So this 147 is the product of 49 and 3. Why did I choose 49 and 3? Well, because 49 is a number that has a square root easily. It's 7. And so you have to play around with numbers in your head to find out what you want to break these into. Let's look at the square root of 5. There's nothing you can break that into. It's just going to be 1 times 5, and you're left with 5, and so you're just going to leave the square root of 5 alone for now. Over here with the square root of 12, it's easy to break it up into 3 times 4, because 4 has a square root that can be taken easily. I didn't choose 2 and 6, because neither 2 or 6 can be taken the square root of. So here we have this. So like I said, I broke these up. So 147 is now 49 times 3. 12 is now 3 times 4. And I noticed that I left them in their square root symbols. So the next thing I'm going to do is, oh, and I did the same thing with 15. Here's 15, it's now 5 times 3. So I broke apart this, and I made it into this. Because remember that when you're taking the square root of a product, you can split apart that product. You can say that that's equal to the square root of 5 times the square root of 3. That's perfectly okay. Once I did that, I could cancel these two. So now I'm done with the square root of 5, and it's a little bit easier. So then I did the same thing with this and this. I broke them apart. So now I have 49, the square root of 49 times the square root of 3, and that's a quantity. And I'm subtracting the square root of 3 times the square root of 4. And again, it's over 3, over the square root of 3. So that means that I can pull out the square root of 3 because it's common to all of these. This quantity, and this single number down here. So once I took them out, it went something like this. I took the square root of 49 times the square root of 3. So the square root of 49 comes easily, so that's 7. And the square root of 3 I can't take easily, so I leave it as is. Same thing over here. The square root of 3 will stay, but the square root of 4 is 2. And it's still over the square root of 3. So that's how that ends up canceling as I did in this step here. Now I'm left with 7 minus 2, which is 5, which is your option for answer C. Question 9 says P, Q, and R are subsets of the universal set U. The Venn diagram showing the relationship which has P intersection Q union R is, and so what you want to do is first remember what intersection and union means. So when you have a union, which could be called a marriage, or you will be taking everything that P and Q have. And what that means is, say I have two sets, and P has flowers and a vase, and Q has a vase and a TV. My final set will consist of flowers, two vases, and a TV, because that's a union. However, if it's an intersection, then you will only be taking the similarities. That means only what P and Q have in common. So now instead of having two vases and flowers and a TV, I'll just have the vase. Well, technically the two vases, because that's what they have in common. Where P and Q have an intersection, and that is combined with the union of R. So P and Q intersect here. And you also want to include what R has. And you can include everything of R. So that's why this circle is covered. The R circle is completely covered because you're including everything of R and only where P and Q intersect, which is there. So that means that your option is C. So 10 is a question about sets, and it says if P is equal to X when X is odd, and negative 1 is less than X is less than or equal to 20, and Q is equal to Y, where Y is prime and Y is in between negative 2 and 25, find P intersection Q. So I've rewritten what they said. So here I have X is odd, and then it has to be somewhere between negative 1 and 20. So that means that your options are negative 1, 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. These are all the odd numbers that fit the criteria in here. Okay, and then except for negative 1, because it is not equal to. That one does not go in there. Anyway, next they said where Y is prime, anywhere between negative 2 and 25. So your options are negative 2, again, that shouldn't be in there because it's not equal to. But anyway, 1, 2, 3, 5, 7, 11, 13, 17, 19, and 23. And so I've tried to highlight in red the numbers that are common between these two sets. Those numbers are going to be 3, 5, 7, 11, 13, 17, 19. And so that's going to be your option A. Question 11 says if s is equal to the square root of t squared minus 4t plus 4, find t in terms of s. So I rewrote it here for clarity, and then I've circled this part because here you'll have a square root. That's kind of hard to work with if you're trying to get t to be by itself. So what I did was I squared both sides. So now I have s squared is equal to t squared minus 4t plus 4. Next, I noted that this quantity here, this t squared minus 4t plus 4, is a difference of squares. So I split it into t minus 2 times t minus 2. And so my next step would be to get t by itself. So I would say I would add 2 to both sides. So now I have t is equal to s squared plus 2. And that's twice because of the square root that happened earlier. So that's your option for B. Question 12 says if x minus 4 is a factor of x squared minus x minus k, then k is, and it wants us to solve for k. So the first thing that we want to do is set x minus 4 equal to 0, because it's going to be a factor of this equation that they give us. So after we set x minus 4 equal to 0, we'll find that x is equal to 4, and then we want to substitute. So since we know that x is equal to 4, this x squared becomes 4 squared minus 4 and the minus k, because we don't have anything to substitute k for. We set this equal to 0, and then we solve for k. So 4 squared is 16, minus 4 is 12, minus k is equal to 0, and so we get that 12 is equal to k, which is your option for answer D. Question 13 says that the remainder when 6p cubed minus p squared minus 47p plus 30 is divided by p minus 3 is, and it wants us to solve for the remainder. So the first thing we need to do is do the division. So I've written out what they said here, and so the first thing I've done was I said how many times does p go into 6p cubed. So what I did was I said, well, that's 6p squared, because if I take 6p squared times just p, I will find myself with the answer 6p cubed, and that's what I was looking for. So the next step to do after that is I write it up here, and then I say, what is 6p squared times the quantity p minus 3? And then that's how I ended up with this part. I had this part will be 6p cubed, and then this will be negative 18p squared. So that's what I did. and then I've subtracted these. So 6p cubed minus 6p cubed is 0. Negative p squared minus 18 minus negative 18p squared is positive 17p squared. So now I start over with the process. I say, how many times does p go into 17p squared? That's just 17p. And then I said, what is 17p times the quantity p minus 3? So I get 17p squared minus 17 times 3 is 51, so 51p. And then I subtracted. And so you'll notice what I did was I brought these numbers down. And that's what you're supposed to do in division. And so then I wrote an extra minus 0 here because there's nothing for this spot when I subtract, and it just kept things clearer for me. So I did my subtraction. 17p squared minus 17p squared is 0. Negative 47p minus negative 51p is negative 4p. Plus 30 minus 0 is just 30. And so now I'm left with p into positive 4p would just be 4. And so I take 4p minus 12, which is what I got down here. 4p minus 12, and I did my subtraction. And so remember, I'm subtracting a negative here. So you add, so you get 30 plus 12 is 42. Obviously, 4p minus 4p is 0. So I get 42, and that's my remainder. Remember that the question that they were asking is, what is the remainder? So this is my answer, 42. Question 1 says, p varies adjointly as m and u, and varies inversely as q. Then it says, given that p is equal to 4, m is equal to 3, and u is equal to 2 when q is equal to 1, find the value of p when m is equal to 6, u is equal to 4, and q is equal to 8 bits. So the first thing that you want to do is you want to make an equation or a formula given that first sentence. P varies jointly as m and u, and varies inversely as q. What they mean there is that p varies jointly as m and u. So m and u are here at the top because it varies jointly. So p times mu, that's how they vary with each other. But it varies inversely as q, meaning that you need to divide p by q. So I've just made these into a fraction. Mu over q times p. Then it says that given that, and then it gives us these numbers for our variables, and it wants us to find the value in p of p when we have these variables. So first we're going to say that there's a missing factor when the numbers change. So I've added this extra k in here so that I know what this missing factor is. So I'm doing the first one, this first line. Given that p is equal to 4, m is equal to 3, u is equal to 2, and q is equal to 1. So I just plug in all those numbers. So now I have p, I have m, u, and q. And I'm leaving the k there so I can figure out how these numbers all change together. So then that means that k is equal to 4/6, which reduces to 2/3. Lastly, the final question that they ask us is find the value of p when m is equal to 6, u is equal to 4, and q is equal to 8/5. So keeping my value of k in here, I plug in my other values, and then I start to solve for p. So 3 reduces to 1, and 6 reduces to 2, and I'm left with 2 times 4 on the numerator over 8/5. So that's 16 over 8/5. And then I can separate that out, 16 over 1 times 5 over 8, because remember that when you divide by a fraction, you can multiply by its reciprocal. And this reduces to 2, this reduces to 1. So now I'm left with 2 times 5 over 1, which is 10, and so your answer is A. If r varies inversely as the square root of s and t, how does s vary with r and t? So r varies inversely as the square root of s and t. So this inversely lets me know that something is going to be underneath the number 1. So 1 over r is equal to the square root of s times t. So I came up with that because r varies inversely as the square root of s and t. So let me, here. So square root of s and t, that's this part. R varies inversely with this. So that means 1 over r is equal to the square root of s times t. That's how I came up with this part. Next, they say, how does S vary with R and T? So the next step I need to do is to solve for S. So what I started to do was I took the square of both sides so that I could get rid of the square root. Now I have 1 over R squared is equal to S times T. Take it one step further, and I'll have S is equal to 1 over R squared times T, because I divided by T on both sides. So now here I am at this point, and so remember they're asking how does S vary with R and T. So what I need to do now, because they want R and T to be alone essentially, so what I did was I took the reciprocal of both sides. So now it's 1 over S is equal to R squared times T. So what is this saying? This is saying that S varies inversely as R squared and T, because R squared and T are together, and S varies inversely with it because it's inverted. And so that's your option D. Question 16 wants us to evaluate this inequality. And so we have 3 times the quantity x plus 2 is greater than 6 times the quantity x plus 3. So what I started out by doing was just multiplying out these numbers. Oops, not there. There. So now I have 3x plus 6 is greater than 6x plus 18. So now I'm going to get x on one side. So what I did was I took this and I subtracted it from both sides. So it's gone here because 6 minus 6 is 0, and over here 18 minus 6 is 12. So now I have 3x is greater than 6x plus 12. Then what I did was I took this and I subtracted it from both sides. 6x minus 6x is 0. 3x minus 6x is negative 3. So now I have negative 3x is greater than 12. Lastly, I divided by negative 3. And remember that when you divide or multiply by a negative number with inequalities, you have to flip the sign. So now it's x is less than negative 4, which is your answer A. Question 17 says the graph above is correctly represented by, and you're supposed to choose the correct answer. So this is a parabola, it has zeros at negative 1 and 2, and it faces concave up. So how did I figure all that out? Well, it has the general shape of a parabola, but also I can see here clearly that it has this point remember points are in x comma y form, so it's negative 1 comma 0, and it has again over here another one where it's 2 comma 0. So it had zeros at negative 1 and at 2, and it's concave up. That's this general shape. That's what we call this, concave up. So the equation for a parabola will look like any one of these essentially. So it has x squared, then x, then a number standing by itself. That is derived from one of these, where you have two quantities of x to the first power of some sort, well, x to the first power plus a number of some sort multiplied by a similar looking quantity. So normally what we would do if we were asked to find the zeros is we'd be given an equation like this, and we'd have to split it up, and then we'd solve for 0 by setting these equal to 0. So I would say x plus 1 is equal to 0, and then I would get x is equal to negative 1, and that would tell me that it was a 0. But we can already tell what the zeros are from the graph, so we can work our way backwards. Now that I know that one of the zeros is negative 1, I can work my way backwards to this point where I have x plus 1. That's where I got this part from. I can do the same thing with this too. Because my final answer was x equals 2, that means that up here, when I set it equal to 0, this was x minus 2. And so that's how I got this part. Then I multiplied this out, so now I have x squared minus 2x plus x minus 2. And then that leaves me, once I simplify, with x squared minus x minus 2, which is option C. Question 18 wants us to solve for x, and it says that the absolute value of x minus 2 is less than 3. So because this is an inequality, we can essentially ignore the absolute value sign and just drop it off. So now we have x minus 2 is less than 3. So then I would add 2 to both sides, and I have x is greater than 5, which is option C. Question 19 tells us the sum of the first two terms is 3, and the sum of the second and the third term is negative 6. Find the sum of the first term and the common ratio. So I've written a few things out just to get a clear idea of exactly what it is that they're asking. Right, so first I labeled off GP, stands for geometric progression, which means that the numbers in this progression will be increasing by a certain factor. And this could, be going up by multiplication or division. And then I've listed out X, Y, Z. Those will be your first three terms, right? And what they're saying is that the first two terms add up to 3, and the second two terms add up to negative 6. I've written out what that means, like just represented by letters. And then I broke down what it is that they want us to find, right? They said find the sum of the first term and the common ratio. So just remember that those are two different things we're trying to find, and at the end we have to add those things up, and that'll give us our overall answer. And I've just labeled that the common ratio is going to be the factor that everything changes by. So first we're starting off with this equation. So this equation right here is the equation that you would use for the sum of consecutive terms in a geometric progression. So knowing that they said that the first two terms add up to 3, we're going to use that. Basically the sum number of terms, right, is going to be equal to the first term A times 1 minus R, where R is the common ratio, to the n over 1 minus R. This is term 2 written out, and then I have plugged in the values that they gave us. They told us up here the sum of the first two terms is 3. So since it's the first two terms, then R is going to be squared. 1 minus R squared can be factored out into 1 minus R times 1 plus R. So that's helpful. And then from there, we can simplify, right? So 1 minus R on top here cancels with this on the bottom. And we're left with 3 equals A times 1 plus R. So that's our first equation. And then now we're going to use the equation for an arithmetic progression. We have here the second term. Well, here's the overall equation. So the second term is going to be represented by this, right? Because n is 2, and we plug that in up here, so 2 minus 1 is 1. So that's our second term, and then our third term is going to be represented by this equation, and I've plugged in the 3 for n instead. And then they told us that the second term added to the third term is equal to negative 6. So A2 plus A3 is going to equal to negative 6, and these being equal to A2 and A3 added up will also be equal to negative 6, so I set them equal to each other. A2 plus A3 is negative 6, and then we just go ahead and simplify, and you see I've pulled out a 1 plus R here, and you'll see why that's useful in a moment. But this is my second equation. And then I want us to find the common ratio, right? That was part of the original question, find the first term plus the common ratio. So for the common ratio, I'm taking equation 2 and dividing it by equation 1. Here's my equation 2. Up here was equation 1. So I do that, and now I've solved for R, and I found that R is negative 2. So that's part of the answer, and they want us to know what the sum of the common ratio and the first term are. So to find the first term, and now that I know R, I can go back and plug that into the first equation. Right, so I know R is negative 2 now, so 3 is equal to A times 1 plus R. And
plug in negative 2 into the equation. When you solve out, M will be equal to negative 3. For the final step, we add the first term, M, to the common ratio, R, which is negative 2 plus negative 3, which is negative 5.
Question 20 wants us to find the nth term of the progression listed here. And so I'll start off with the denominator because I think that will be easier for me to explain and move on to the numerator. So with the denominator, what's happening? So it goes 2, 3, 4, 5. It's pretty easy to tell that it's just going up by 1. So, and it starts with 2. So the first term of the sequence, this term right here, the first term, that means that n would equal 1. So 1 plus 1 is 2, and I'm easily arrive at the denominator's first term. And then if I want to get the second term, I can plug in 2 plus 1 is 3, and so on and so forth. And all I have to do is add 1. However, up here at the top, you'll see that it's going up by 3. 4, 7, 10, 13. Not only that, but it starts off with the number 4. So how do I fix that? Well, first off, let's think how we can get there, kind of like we did down here. So this whole n plus 1 thing. How can we get it to work for the number 4 instead of the number 2? Well, you can say 3n plus 1, because 3 times 1 is just 3 plus 1 is 4, and we're there. And it turns out that this can continue to work, because then the next number that you plug in, so 2 times 3 is 6 plus 1 is 7. 3 times 3 is 9 plus 1 is 10. So using this 3n out here easily advances you by 3 each time. And so yeah, so this is your answer. It's option B. Question 21 says, if a binary operation star is defined by x star y is equal to x plus 2y, find 2 star times the quantity 3 star 4. So imagine that you just crossed into another world of math, and in this world they use this symbol. And this symbol always means to do this. This you are used to. So they want you to find what 2 star times the quantity 3 star 4 is. Remember, by your basic rules of operation, that you always do what's in parentheses first. So we're going to start off with this 3 star 4. Okay, so what would you do with 3 star 4? Looking back to this, you're going to take the first number and add it to 2 times the second number. So the first number is 3, and you're adding it to 2 times the second number. So 3 plus 2 times 4. So that means that this quantity is now represented by this, which you can do easily, is 3 plus 8, which is 11. So yeah, so I rewrote it, and so I said instead of the quantity 3 star 4, I wrote the quantity 3 plus 2 times 4. And remember that you're still going to do something with that once you figure out the inside. You have to take 2 star whatever you get. So I went ahead and solved, and I said 2 star times the quantity 3 plus 8, which is 11. So now I have 2 star 11. So now I'm just going to do the same process again. I'm going to take 2 plus 2 times 11, because that's what this original process told me to do. So 2 times 11 is 22, and 2 plus 22 is 24. And that is option C. Question 22 wants us to find 2p plus q when p is equal to 5, the matrix 5, 2, 3, 1, and q is equal to 4, 3, 2, 5. So, well, first I found what 2p was. So here I had p, 5, 2, 3, and 1. And I just multiplied by 2. So now 5 times 2 is 10, 2 times 2 is 4, 3 times 2 is 6, and 1 times 2 is 2. And I'm adding it to q. So my next step would be to simply add these numbers up. And so you just add what's in the same spot, in the corresponding spot. So here we have 10 plus 4 is 14. 6 plus 2 is 8. 4 plus 3 is 7. And 2 plus 5 is 7. And so your answer is option D. Question 33 wants us to find the inverse of the matrix, which consists of the numbers 5, 3, 6, 4. So to take the inverse for a 2 by 2 matrix, you can follow this formula over here. So if the first inverse is set up, if the first matrix is set up like this, A, B, C, D, then to get the inverse, you're going to take 1 over the determinant of the first matrix times the numbers of the first matrix jumbled around like this. So A and D switch places, and C and B stay where they are, but they become negative. So let's apply that to this over here. So this will be our original. So here we have 5, 3, 6, and 4. So we can find the determinant by taking 5 times 4 minus 6 times 3. And then, so I set that up here, and we can simplify that later. And then to get the second part that we need of this formula, we're going to switch the places of the A and the D numbers. So 5 and 4 switch. So now 4 is here and 5 is here. And then you're going to leave C and B where they are, but you're going to make them negative. So now this is negative 6 and this is negative 3. So moving on, we're going to simplify. This is 1 over 20 minus 18, which simplifies to 1/2. So now we're just taking this 1/2 and multiplying it by the numbers in this matrix. So now we have 1/2 times 4 is 2, 1/2 times negative 6 is negative 3, 1/2 times negative 3 is negative 3/2, and 1/2 times 5 is 5/2. And so that matches your option D. Question 24 says, in the diagram above, find the value of x. So here we have two triangles, and they want us to find the value of x. So we're going to use what they gave us to our advantage. So this angle right here is 150 degrees. This one is 110, and we want to know x. So first, and hopefully you can see the line that I'm drawing, this straight line, well, first off, it's a straight line. Straight lines have a measure of 180 degrees. So this full angle right here is 180. If I subtract 150, I'll have this inner angle. So 180 minus 150 is 30. Okay, so now I know that this inner angle is 30. I know that inside of a triangle there are 180, so I'm getting pretty close to finding out what x is. Next, I'm going to add these two angles. So 30 plus 110 is 140. And now, to find out what x is, all I have to do is take the full measure of the triangle, which is 180 degrees, and subtract 140, because that's how much these two are added up together. So now, my final answer is 40 degrees for angle x, which is option D. Question 25 wants to find out what the value of x in the figure is. So what we need to do is take our knowledge of parallel lines and angles and put it all together. So first off, we know that since this is 110 and this is a straight line, this full angle is 180, meaning that 180 minus 110 tells us that this inner angle is the 70 degrees that I've labeled up here. Using that same process of information, I took 180 minus 120, and I got that this inner angle was 60 degrees. And then because this diagonal was crossing through the two parallel lines, this being 70 degrees makes this angle also 70 degrees. Okay, so that helps me out a lot more. So now I know that this is 60. And this is 70, making this final angle here 50. And that's because 70 plus 60 is 130. So 180 minus 130, going from here to here, 180 minus 130 is 50. So remember back to the question that they're asking us, which is what is the value of x? So now I know that this is 50, this inner angle here. And so the value of x is going to be, and now this is starting to get kind of crowded, I know, so I'll try to find a different color and maybe make the line a little thicker. I don't know how much thicker. Okay, that's good. This straight line here is still 180. This inner angle here I just figured out was 50. That means that 180 minus 50 will give me the value of x. So 180 minus 50 is 130, and the answer is B. Question 26 gives us the angles of a quadrilateral, and it tells us that it it tells us, it asks us to find the value of y. So in a quadrilateral, there are 360 degrees total. So that means that if I were to add up all the measurements that they gave me, I would get 360. So what I did was I took all of these and I added up as best as I could. So 3y plus 2y is 5y, plus 1y is 6y, plus 4y is 10y. So that's how I ended up with this, 10y. Then I took 10 plus 30 is 40, plus 20 is 60. So here I'm at 10y plus 60 is equal to 360. So the next thing I did was I subtracted 60 from both sides. So I'm left with 10y is equal to 300. I divide by 10 on both sides, and I find that y is equal to 30, which is your option C. A square tile has a side of 30 centimeters. How many of these tiles will cover a rectangular floor of length 7.2 meters and width 4.2 meters? So, the total area for this rectangular floor can be found by multiplying. Also, notice that they gave me this, meters, but this one is in centimeters. So what I did is I converted this 7.2 meters into centimeters and the 4.2 meters into centimeters as well. The way that I did that was I just moved the decimal point over 2 spaces because it's multiplying by 100. So 7.2 times 100 would simply be 720. So that's what I did for both of these. So to find the total area, I would have to multiply 720 times 420. So, but before I go on and do that, that's my total area, right? But what are they asking me? They're asking me how many of these tiles will cover a rectangular floor. So what I did, and I wrote it out here, to get tiles needed to cover area, divide by area of one tile. So again, they told me that one tile has one length that is 30 centimeters, and because it's a square, so is the other one. So the area of the tile is going to be 30 times 30, which I wrote here. So what am I doing here? What is this step? Well, I'm taking the area of the room divided by the area of one tile. This saves me from having to do the math of first 720 times 420, then 30 times 30, then this number divided by this number. This way I can just easily simplify as I go. So I crossed out these zeros, and I'm left with 72 over 3 times 42 over 3. And so I went ahead and I simplified that. So I know that 72 divided by 3 is 24. And you can see my scratch work over here on the side. I knew it would go into it. And then 42 divided by 3. The way that I knew that I could divide these easily is because 7 plus 2 is equal to 9, which is easily divisible by 3. And 4 plus 2 is equal to 6, which is easily divisible by 3. That's this trick of checking if you can divide by 3 only works with the number 3. But anyway, so I did 72 divided by 3, and I got 24. And I did the same thing for 42, and I got 14. And then I finally multiplied those two numbers. I got 336 tiles as my answer. And that is option B. Question 28 wants us to find the length of a chord which subtends an angle of 90 degrees at the center of a circle whose radius is 8. So here I have a circle, and it wants us to find the length of a chord which subtends an angle of 90 degrees. So here is the 90-degree angle which they speak of, and the radius is 8 centimeters. So that means that, pretending that this is the center, going out is 8 and going out here is 8. So the next thing we need to do is use the Pythagorean theorem. So this length, AB squared, is equal to 8 squared plus 8 squared. So I'll have AB squared is equal to 64 plus 64, which 64 plus 64 is 128. So I'm taking the square root of both sides. So now I have AB is equal to the square root of 128. I split that apart to make it a little bit easier to work with, so that's 64 times 2, as I just saw up here. That means that I can take 8 times the square root of 2, and that will be my final answer for length of AB, which is the chord that they were asking about. And that's your option D. A chord of a circle subtends an angle of 120 degrees at the center of a circle of diameter 4 square root 3 centimeters. Calculate the area of the major sector. So, they said here that the diameter is 4 square root of 3. I wrote that out here, that's the diameter. So our radius will be half of that, so it's 2 square root of 3 for the radius. And remember that the radius is only this length. The area of a circle is pi r squared. So I plugged in this radius here. And I squared it because, well, that's what you have to do for the area of a circle. So I'm left with 4 pi cubed, or excuse me, 4 pi times 3. So that was equal to 12 pi. 4 times 3 is 12 pi, and that's the area of the circle. But remember, they're asking to calculate the area of the major sector. So what do I have to do next? Well, remember that they said that it's subtending an angle of 120 degrees. So the entire circle has 360 degrees. The area they're interested in is 120 degrees of it, which means I'm dividing it into 3 parts. So I'm only interested in 1/3 of the full area of the circle. So here's the full area, and now I divide it by 3 so I can get the 1/3 that they're interested in. And so my final answer is 4 pi centimeters squared. And that's option B. Question 30 says the locus of the points which is equidistant from the line PQ forms A. And so I drew a simple diagram to illustrate the point here. So the line PQ is here, and they want the locus of the points that's equidistant from this line. Well, that would be a perpendicular line to PQ. And I'll even try to draw a line that's perpendicular here. It's not very well drawn, but you can imagine. So that line, this line, consists all points that are equidistant. So this point and this point equidistant. This one and the next one equidistant, and so on and so forth. So that's why the answer is A. Question 31 says if the midpoint of the line PQ is 2, 3, and the point P is at -2, 1, find the coordinate of the point Q. So I drew an illustration to illustrate the point. So here we have -2, 1, which they told us is point P. Then we need to know Q, which I've labeled with question marks because we don't know what it is yet. But we do know that the midpoint is 2, 3. So to get to the final answer of Q, I've drawn a bit of a number line here. So here we have -2 and 2. So those are values on the x-axis, because remember that a coordinate pair is given to you in the x, y form. So from -2 to 2, how many spaces did we pass? Well, 1, 2, 3, 4. So 4 more will get us to the next point, since that's the midpoint. So 4 more onto 2. 2 plus 4 is 6, so that's your x. Then we do the same process for the 1 and the 3. How far apart are the 1 and the 3? Well, they're only 2 spaces apart. So 2 more onto the midpoint will take you to the last spot that you need to be at. So 3 plus 2 is 5, and that's your y. So in x, y form, x is 6 and y is 5. So 6, 5, option D is your answer. Alright, so question 32 asks us to find the equation of the perpendicular bisector of the lines joining point P and Q, where P is 2, -3, and Q is -5, 1. So I've gone ahead and drawn us a picture here so we can see exactly what the question is asking for. So when q is -5, 1, remember that ordered pairs are given in the form of x, y. So for x, we go to -5, and then for y, we go to +1. And p would be 2, 3, so we'd go forward in the x direction 2 spaces, and then down in the y direction 3 spaces. So that's our q, and that's our point p. And so here is the line that connects them. And it wants us to find the equation of the perpendicular bisector. So I've drawn a line that would be the perpendicular bisector of it, or approximately anyway. And so basically what that means is that these two lines form a 90-degree angle here. And in order to find the equation of that line, first we need to find the gradient of the first line. So the gradient of the line joining point P and Q would be the change in y over the change in x. So the change in y positions here is, let's see here, so here's here's -3 in the y direction, and here's +1 in the y direction. So we can see that it changed a total of 1, 2, 3, 4 spaces. That can also be represented by writing -3 minus, we'll leave it at that. -3 minus 1, and then for the x direction, we keep it this, since we use this as the first number, we're going to use this as the first number in the x ones, right? So now we do 2 minus -5. Right, and so we're going to get -4 over, and this becomes 2 plus 5, so it's -4 over 7. Right, so we see that we move down 4 spaces and to the right 7 spaces. So this makes sense. Now, this is the gradient of this line. What is the gradient of the line right here? Well, it's important to note that when you have a perpendicular bisector, the equation of the two lines will have slopes that are opposite reciprocals of each other. So what I mean by that is that in order to find the gradient of the new line, we have to take the opposite reciprocal of this, or negative reciprocal. So that means that we change the sign, so it was negative and now it's positive, and we flip it to make a reciprocal. So now it's 7 over 4 instead of 4 over 7. So this is our new gradient of our perpendicular bisector line up there. Now, they want us to find the equation of the perpendicular bisector line, right? So so it's the perpendicular bisector. So what that means is that, see, I could have drawn another line out here that would have been perpendicular to this line, but it wouldn't be the bisector because it wouldn't be exactly at the middle. And so to find the bisector of the line joining Q and P, we are essentially taking the average of our different positions. So here's -5, and here is +2 in the x direction, right? And so the midpoint of that is essentially the average of those two values. So we're going to go out, so it's -1.5 here, because if you go from 2, you go out with 1, 2, 3.5 spaces. That leaves you over here with 1, 2, 3.5 spaces, right? So the halfway between here happens to be at -1.5. And then now we have to take, right, where on this line is it? So that would be at halfway between 1 and -3. So, right, because it's at 1 up here and -3 down here. So halfway between that gives us -1. Right, so you go down 2 spaces and you write a -1, but from here you go up 2 spaces and you write a -1. So that's the midway point for the x and the y. So now we know that this perpendicular bisector line goes through the point that has -1.5, -1, and it has a gradient of 7/4. And then knowing that the equation of a line can be represented by y equals mx plus b, we plug in our gradient, and then we can solve for what b is by using the point that we have. So we plug in -1.5 for x, so that's -3 halves, and -1 for y, and we solve for b. And so you can see I've done our math here, and you get b is equal to negative 13 over 8. So that means that this is the equation of the line here that you've been looking for the whole time. But you'll notice that they have it in a different form. They don't have it in y equals mx plus b. They have it solved for 0. But that's okay. We can easily just solve this equation for 0. And so what I did is I multiplied by 8 on both sides. So when you multiply by 8, I'll show you. Multiply by 8 on this side as well. So these cancel. 8 times 7/4 is going to be 14. And 8 times y is 8y. And then you just go ahead and move everything to the other side to solve for 0. And you get 8y minus 14x minus 13 is equal to 0, which is your option C here. So I've drawn a diagram here from question 33, and we need to use this equation to solve for the value of p. And so what I've done, remember that when I write the small letters, which this should be a lowercase p, that's the lowercase, if I can get this to go away, there you go. That means that I'm referring to the lengths that are opposite from the side, or opposite from the corner, excuse me. So this would be little p, this would be little q, and this would be little r. So essentially, if I want to know the length of p squared, I have to plug in these other values. So p squared is going to be equal to 8 squared, because that's what q is over here, plus 6 squared minus 2qr. And so I've done some simplifying. And then you also have to, sorry, I forgot to add, you have to use this part right here. So this cos. Okay. So then, let me make this clear, open this in parentheses here. So then you go ahead and simplify. So 6 will reduce to 1, while 12 reduces to 2. Then this 2 and this 2 will cancel into 1 and 1. So I'm left with just the number 8. Because this is 1, and this is 1. So now I have 64 and plus 36 minus 8. So 64 plus 36 is 100, minus 8 is 92. So p is equal to the square root of 92, which is your option for C. Question 34 asks us to find the value of the sine of theta plus the cosine of theta. And it gives us the tangent of theta is equal to 3/4. So if you have this mnemonic SOHCAHTOA, you can remember that the tangent is equal to opposite over adjacent. That's what the O and A stand for. So here we have theta on a right triangle, and the side length opposite it is 3, because remember they said 3/4. And so then we need to find what the adjacent side length is. That would be this one, and that's going to be 4. And then this is a Pythagorean triple, so that means that 3 squared plus 4 squared is equal to 5 squared, and that's an easy one to remember. But if you didn't remember it, you would just write it out. 3 squared plus 4 squared, which you'll find is 9 plus 16 is equal to 25, and the square root of 25 is 5. So that's how I got the last length there. Next, we need to find what the sine of theta is. Remember, sine is opposite over hypotenuse, so we're going to take the opposite, which is 3, and we're going to put it over the hypotenuse, which is 5. Then we're going to do the same thing for cosine, but cosine is adjacent over hypotenuse, so this time I'm going to pay attention to the 4 over the hypotenuse, which is 5. They have a common denominator, so you can easily add them to 7/5, and then you're going to reduce to 1 2/5, because 5 goes into 7 once, but it leaves you with 2 left over, so 1 2/5, and your option D is going to be your answer. Question 35 basically wants us to find the derivative of the quantity 2x plus 2 cubed. So the first thing that you're going to do is realize that this is a compound function with an inside and an outside. And so first we take care of the outermost function. So the outermost function is x cubed. So the derivative of x cubed, remember, if I were to take dy dx of it, dy dx, so the derivative with respect to x would be 3x squared. So that's where I get this and this. And then I left the inside, because that is my x, that's my standing x now. But we're not done because there's an inside function, and so that means we have to use the chain rule. So the next step would be to take the derivative of the inside and multiply it. So remember the chain rule, you're taking the derivative of the outer and evaluating it at the inner, multiplying by the derivative of the inner. So derivative of the inner, what is dy dx of 2x plus 2? Well, this 2 will just turn into a constant. Well, the 2 is a constant, so when you take its derivative, it's 0. And the derivative of 2x is simply 2. So that's where this comes from. Next, you just want to simplify. So 2 times 3 is 6. And I'm leaving this quantity squared. And your answer is going to be B. Question 36 says if y is equal to x times the sine of x, find dy dx. So for this one, we have to use the product rule. And so that says that we're going to take the derivative of the first part and multiply it by the second part left alone. Then we're going to take the derivative of the second part and multiply it by the first part left alone, which sometimes will be written like this. It'll be x prime times y plus y prime times x. So here we go. Taking the derivative of x is just 1 times the sine of x. I left that alone. Then I'm going to be adding it to the derivative of sine of x is cosine of x, and this time I leave the x alone. So my final answer is going to be sine of x plus x times the cosine of x, which is option B. Question 37 says the radius of a circle is increasing at the rate of 0.02 centimeters per second. Find the rate at which the area is increasing when the radius of the circle is 7 centimeters. So first off, we know that the rate of the radius over time is increasing at a rate of 0.02 centimeters per second. Remember that when you see second inverse, you can just read that as per second. We also know what the area of a circle is. It's pi r squared. So the first thing we need to do to be able to answer this question is to take the derivative of the equation for the area. So now we have dA dt is equal to pi times 2 pi r times dr dt. So where did that come from? Okay, so the derivative of r squared is just 2r. However, I'm taking this with respect to time. So I have to respect my time. So I have to put times dr dt because of the chain rule, essentially, is why we do that. If I were taking this with respect to r, I wouldn't need to add this, but because it's respect to t, I do. So now what? Well, now we plug in our dr dt, which we labeled up here as 0.02. The rate of change of the area is going to be equal to these numbers. And you'll notice that I replaced my r with the number 7, and that's because they wanted to find what the rate is increasing at when the radius of the circle is 7. So I've replaced the radius with 7 because that's what they wanted. So now I have, I took these two and I multiplied, and that's how I got this number. And I'm saying times 7 times pi. Remember, I left pi alone because pi is just another number. So that would be 0.28 times pi, and then, so you can see I did my math for that over here, and then I substituted 3.14 for pi, so I could come up with a good approximate answer, and my answer was very close to 0.88 centimeters squared per second, which is your option for B. Question 38 wants us to integrate. And so this is what we're integrating here, this 1 plus x over x cubed. So the first thing I did was I split this up. I said 1 plus x over x cubed is the same as saying 1 over x cubed plus x over x cubed. That allowed me to make two different integrals that I could work with separately. So 1 over x cubed is the same as saying x to the negative third power. To take the integral of that, I would get x to the negative 2 over negative 2. And then over here, I took the same idea. I said x squared is the same, 1 over x squared is the same as saying x to the negative 2. To get the integral of that, I would get x to the negative 1, negative x to the negative 1. And I'm remembering to add plus k at the end to stand in for both of them. So I technically should also have a plus k here, but they will combine into this 1k, and so that's why I only wrote it once there. Anyway, so then I'm left with negative 1 over 2x squared plus negative 1 over x and plus k. So you might be wondering how I got from this to this. Well, remember that when I have a negative exponent, it means to put it on the bottom. So that's where this x squared comes from. This negative 2 was already here. Well, the 2 stays on the denominator, but the negative it doesn't matter where the negative is. Same idea over here. So x to the negative 1 means I have x to the 1 on the bottom, and it's negative. That's why the negative is there. Also, to be able to achieve or arrive at the answers for your integrals, you want to think backwards in a sense. So remember that when you take a derivative, if I'm taking the derivative of, say, x to the negative 2 power, let's say dy dx, I will get x, well, ddx, I guess. I will get x to the negative 3 times negative 2. Because this comes down, that's where this comes from, and then I subtract 1, which is almost where that started, but remember they don't have this negative 2 here, so that's why I have to put negative 2 on the bottom here, so they will cancel each other out. So yeah, you have to practice with your derivatives so you can be able to think backwards like that and figure out what type of thing you would have started with to get here. But yeah, like I said, you arrive here, and so your answer is option B. Question 39 wants us to evaluate the integral of the sine of x dx going from 0 to pi over 2. So the integral of the sine of x is negative cosine of x, but remember they want us to go from 0 to pi over 2. And so I drew over here a little unit circle to remind you what that means. So I wrote, well, you want to start with the uppermost, or the one that has the most value, because it's 0 to pi over 2. So we'll start off here. So the negative cosine of pi over 2 minus the negative cosine of 0. And so the cosine of pi over 2 is just 0, and the cosine of 0 is 1. So you can see that over here, the cosine of 0 is 1, and the cosine of pi over 2 is 0. So you're just taking 0 minus 1 essentially, so your answer is negative 1, which is option D. Question 40 says the bar chart above shows the allotment of time in minutes per week for selected subjects in a certain school. What is the total time allocated to the 6 subjects per week? So remember the final question says what is the total time for the 6 subjects? So all you have to do really is add it all up. So biology has 80, English language has 160, maths is 200, geography is 80, chemistry is 120, and physics is also 80. So I've listed the numbers here, and I've added them. So here you go, this is 0, you'll get 31 when you add all of these, you bring up the 3, then you add and you get 7 here, and that's very close to 720, and I cut off option D on accident, but that would be your answer, would be option D, 720. Question 41 says the pie chart above shows the statistical distribution of 80 students in 5 subjects in an examination. Calculate how many students offer mathematics. So, since it's a pie chart, you know that a circle has 360 degrees total, and these are all given in terms of degrees. So you can add all of these up and solve for x, and then solve for how much math is worth. So 6x plus 12 comes from here. Then I add the 5x, another 5x, the 16x minus 24, and the 4x plus 12. So I combined all my like terms. And so adding all of these, I got 36 right here. And then all of these, 12, negative 24, and 12 add up to 0. So now I have 36x is equal to 360, meaning that x is equal to 10. Now that I know what x is equal to, I can figure out how much math is worth. So 5 times 10 is 50 degrees. However, that's not the full question. So, question 41 says, calculate how many students offer. So how many students? Well, there's a total of 80 students. So what you're going to do is you're going to say 50 out of the 360 is the same as saying 5/36, or approximately 5 over 35, which is 1/7. Well, what's 1/7 of 180? Well, that would be 11.4, which is not an option. It's actually not anywhere near any of your options, and so you would leave it blank. Question 42 wants us to find the mean of these 4 quantities. So remember that they're giving us 4 separate quantities. Oh, sorry, that's one, and then that's another one. And so that means that there's 4 terms total. That comes in handy later on. So the next thing that we need to do is add all of these up. So I combined my like terms with all the t's, and I got 8t. These other numbers without the t's happen to add up to 0. So I'm just at 8t. And that's how much, that was their sum. But to find the average, I need to take that sum and divide it by how many terms there were. So that's why I divide by 4 here. So I have 8t divided by 4 is equal to 2t, and so my answer is option D. Question 43 says the mean of 7 numbers is 10. If 6 of the numbers are 2, 4, 8, 14, 16, and 18, find the mode. So the mean of the numbers is 10. That means the average. So the sum over the number of terms gives me 10. So that means that the sum is going to be 70 if I just solve for the sum here. So sum is equal to 70. Also, we know 6 of the terms. So I listed them here, and then I added plus x to get the 7th term, and then set it equal to 70. I added up all of the numbers, and I got 62 plus x is 70. Then I solved for x, and I got x is equal to 8. 8 was another number that showed up here. Because remember, the final question that they're asking is, what is the mode? That mode is the number that shows up the most frequently. So 8 is here, and 8 is here. It's the only number that shows up more than once, meaning that your mode is 8. So your answer is option D. Question 44 wants us to calculate the median age of the frequency distribution in the table above. So basically it just wants us to find the median. So we have to list these numbers out in order from least to greatest, and that's actually fairly easy to do with the way that they've presented us with the information. So they've already listed it in least to greatest. So now all we have to do is list the frequencies of each one. So 20 shows up 3 times, so I wrote 23 times. There was 5 people with 20 that were the age of 25, so I wrote 25 5 times. 30 showed up once, 35 once, 40 twice, and 45 5 more times. So then what you have to do here is find the number that's in the middle. So let's see if I did this right, because I'm realizing that these are out here and they don't have slashes through them. So let's try it. the number in the middle would be, well, I'd cross off this one, and then this one, and then this one. And you just keep going. The simpler way to do this is to see how many numbers you have in total, and then divide it by 2, and then you'll be easily arriving at your center, which, by the way, is not going to be 25. Your center is 30. So your answer is option D. Question 45 says if the variance of 3x, 6, 4x, and 7 minus x is 4, and the mean is 5, find the standard deviation. So variance is the same thing as taking the standard deviation and squaring it. And so they just told us that the variance of these numbers is 4. So you don't even have to do anything with these numbers. All you have to do is know that standard deviation is the square root of variance. That's the relationship that they have. So that means that since variance is 4, I take the square root of 4 and I get 2. And that's my standard deviation, so that's option D. The table above shows the scores of 20 students in further mathematics test. What is the range of the distribution? Just remember that range means you take the highest number and subtract the lowest number. So the highest number was 10 and the lowest number was 3. You don't even have to pay attention to the frequencies. You just say 10 minus 3 and you get 7, and your range is C. Question 47 says, in how many ways can a student select 2 subjects from 5 subjects? So this would be 5 choose 2, which the formula to use here would be n factorial over r factorial minus n minus r factorial. And so remember, you do n choose r. So 5 choose 2, 5 goes in for n, 2 goes in for r. And so then you're left with 5 factorial over 2 factorial times 3 factorial in the denominator, and that would be your option A. Question 48 says, in how many ways can 3 seats be occupied if 5 people are willing to sit? And so this is a type of permutation. So the formula for this is just n factorial over n minus r factorial. So you have n is your total number of people, so that would be 5. And r is the 3 seats that can be occupied. And so you're going to do 5 factorial over 2 factorial. 5 minus 3 is 2. And so you can write these out. 5 times 4 times 3 times 2 times 1. 2 times 1. And then you cancel out these numbers that appear in the denominator and the numerator. And you're left with 5 times 4 times 3, which is 20 times 3, which is 60. So your final answer is C. Question 49 says, what is the probability that an integer x, where x is between 1 and 25, including 1 and 25, is chosen at random, is divisible by both 2 and 3? So first off, you need to know how to check for a number that's divisible by 2 and divisible by 3. So to check if a number is divisible by 2, you just have to see that the number is even. To check if a number is divisible by 3, you just have to see if the numbers add up to a factor of 3. So for instance, 6 is a factor of 3, so that's easy to do. 12 might be easy to do in your head, but also notice 1 plus 2 is 3, which is a factor of 3. With 18, 1 plus 8 is 9, that's a factor of 3. 2 plus 4 is 6, that's a factor of 3. So first I crossed out the odd numbers because those would not be divisible by 2. Then I checked for out of the numbers that were left, I checked for those that were divisible by 3 and I circled them. And so they want to know what is the probability that an integer chosen fits this criteria. So my total number of options here, if I were to count up all my options, is 25, but only 4 of them fit my criteria. So 4 out of 25 is the probability, and my answer is A. Question 50 says a basket contains 9 apples, 8 bananas, and 7 oranges. A fruit is picked from the basket find the probability that it is neither an apple nor an orange. So you will have 9, 8, and 7 of each kind of fruit, and you add them up to figure out how many you have possible. That will be your denominator. Then you need to put what you want on top. So not an apple, not an orange means that you only want bananas. So 8 out of 24, and then you reduce that to get 1/3, and your answer is option D.